Hi, this is Mrs. Westmoreland, and this video is to help you with some of the post-lab questions on the limiting reactant lab. So here you can see a data table where instead of numbers I've just put letters, and that's so that you can sort of get an idea of the setup of these calculations, but you'll have to use your numbers that you actually measured in the lab. For your post-lab quiz next week, you'll get a data table that looks a lot like this. So it's helpful to know kind of where you get each piece of data to do each one of the calculations. So in this lab, we were told that it's a single replacement reaction and that we know that we started with the elements aluminum wire, and then the copper 2 chloride solution. So on your post-lab quiz, as well as in the first question of the post-lab questions, day 1 questions, you need to write the balanced chemical equation. So aluminum's an element, not Brinkelhoff, so it's just written as Al, and the physical state is solid. We saw that it was solid. And then the copper Roman numeral 2 chloride is an ionic compound, which we need to balance out the charges. So Roman numeral 2 tells me copper is +2. Chloride is -1 because of its position on the periodic table. So CuCl2 is the correct formula for copper 2 chloride. And that one we dissolved in water, so physical state is Aq. Then this is a single replacement reaction. So aluminum is a metal, which means that when it takes the place of one of the elements in the compound, it's going to take the place of the metal. So the aluminum takes the place of the copper. So we have copper, the element, as one of our products, not Brinkelhoff, just Cu, solid, and that was what we collected, the red solid that we collected. And then the aluminum takes the place of the copper, so now it has formed a compound with chloride. But aluminum as an ion is +3, balanced out with the chloride, which is -1, to make AlCl3. So first I have to write those 4 correct chemical formulas, and then and only then can I add the coefficients to make the equation balanced. So the clear liquid that you decanted on the second day of the lab, that actually was an aqueous aluminum chloride solution. So the first question asks you to use the mass of the copper 2 chloride to find the mass of copper that should have been produced. So the idea here is, if we used up all the copper 2 chloride that we weighed out, how much copper should be in the beaker on the last day of the lab? So we have our mass of copper 2 chloride that is in the data table as letter B. And so my dimensional analysis setup is how many grams of copper are equal to B grams of copper 2 chloride. So I have to take my trip across mole land that we've done several times now, where I'm starting with grams of one chemical, and then I need to go to moles, because the equation speaks molish. So the first step is the molar mass of the copper 2 chloride. Once I get to moles, then, because the equation speaks molish, I can cross the mole ratio bridge using the coefficients from the balanced chemical equation. So in this case, every time 3 moles of copper 2 chloride are used up, I'm going to form 3 moles of copper. And then finally, once I have moles of copper, I can get to grams of copper using the molar mass of copper. So this is 3 legs of a journey on the map of mole land, so I need 3 fractions to multiply by. So I've just given that answer a letter also of X grams of copper. Then in number 3, we're using the mass of the aluminum metal that we started with. So in the data table, the mass of the aluminum metal that we started with is letter C. So here I'm saying how many grams of copper should be in the beaker on that last day of the lab if I start with the C grams of aluminum and use it all up. So same trip across mole land, from grams of aluminum to moles of aluminum using the molar mass. Then cross the mole ratio bridge using the coefficients. So every time 2 moles of aluminum are used up, I form 3 moles of copper. And then once I get to moles of copper, I can use the molar mass of copper to get to grams of copper. So I have 2 answers of grams of copper. And this is what makes limiting reactant problems a little bit different. You do the dimensional analysis twice. So I weighed out 2 different reactants. and I need to figure out which one's going to run out and which one is going to have some left over. And so when I do the math this way, by doing the dimensional analysis 2 times, whichever one is my smaller amount of copper is the true amount that forms, or that could form. If the limiting reactant runs out, the reaction stops. So you can't make any more product than what the limiting reactant will allow you to make. So what you're going to do is you're going to compare your answers to X and Y. Whichever one is smallest is the true answer. And whichever reactant you started with, so in the dimensional analysis setup, whichever one you started with to get the smaller answer is your limiting reactant. So in number 4, you're supposed to choose the limiting reactant, and number 5, you're supposed to choose the excess reactant. So in this case, the limiting one is the one that gives you the smaller answer. And it turns out, or it should turn out, this lab was designed so that the copper 2 chloride was your limiting reactant. That means that the excess reactant is the aluminum wire. So then the day 2 questions, number 6, asks you about what you see in the beaker on the second day that really supports what your calculations in number 2 and 3 told you. So by doing calculations, we can figure out what the limiting reactant is. But we can also figure out what the limiting reactant is in the lab because we see some things. And the 2 things that we see on the second day of the lab is that there's still aluminum wire left in that beaker. We clean it off and dry it off and take its mass again. We take the after mass of the aluminum. There's still aluminum left. It's excess. And the other thing that we see that sort of supports our conclusion that the copper 2 chloride is our limiting reactant is the one that gets all used up. And so if you recall, on the first day of the lab, when we weighed out the copper 2 chloride and then dissolved it in water, that was a blue-green chemical. On the second day when we came back, there was none of that blue color remaining. The solution had turned colorless. And so because all of that blue-green color is gone, that's a visible evidence to say that all of the copper 2 chloride has been used up, therefore the copper 2 chloride is limiting. So I hope this helps you to complete your lab questions and begin to get ready for your post-lab quiz next week. I'll see you in class.